Okay, good day. It's time for us to do trigonometry, and this is going to be a very brief one. So, trigonometry, looking at the name, it has a triangle component and then measurements. So measurements that take place in triangles. Okay, and at the SHS level, trigonometry is divided into three different sessions. So the trigonometric ratios and their rules, that's the first session, and then compound and multiple angles, and then the last one is trigonometric functions. So today we are going to delve into the trigonometric ratios. Okay, and that will be due. So you can see this nice Cartesian plane. So let's consider it the vertical, horizontal. This is the x-axis. You know the horizontal one is the x-axis, and then the vertical one is the y-axis. So we assume that there's a point here. Okay, yes, any point at all in the Cartesian plane represented by the coordinates x, represented by x and y. Okay, so you know that if this is represented by x and y, then from this point to that point, assuming we are projecting this point onto the axis, so we project the point downward. So from here, we project downward to this part. So from the origin up to this point is our x coordinates. Okay, and then from this side to that side, okay, that can be given as this point to that point will be our y value. Okay, and then if this is a circle, this is the center. The distance from the center to touch any point on the circumference is what the radius is. That not it? That's why we represented that by r. Okay, so if we have that, mm, then we are going to use the principle of SOHCAHTOA. I hope you remember the principle of SOHCAHTOA to determine the various trig angles. Okay, okay. So we know that we have three basic trig functions. Okay, which are what? Sine, cosine, and then tangents. Okay, so these are the three main trig ratios. Okay, now let's assume, so we are going to draw our graph again. So assuming we have this graph here nicely, we have this graph nicely here, and then there's a point, so the point that we had already. So assuming we have this point here. So let's make the point a big one. So assuming we have this point here, and this point is represented by the coordinates x and y. Okay, we know that a straight line that is drawn from here to pass through the point will be represented by our r, which is the radius. Is that not it? Good. If that is so, then we know we can project the horizontal line, which is our x-axis. So this is our x, okay? So, and then this is going to be our y. Okay, we just projected this line. If we project the point towards the y, the distance from the origin to the y point is our y distance or the value of our y. Okay, and this is represented here because this line has the same length as that line. Okay, and then the same applies to x. So if this is the angle that we are considering, the angle is theta. So if this is a theta, okay, we know we have SOHCAHTOA. So ka and toa. So from the principle of SOHCAHTOA, let's look at what our sine is going to be. So sine, sine theta is going to give us what? Sine theta will be, opposite. And since this is the angle, this is going to be the opposite because this angle is 90 degrees. Okay, so the opposite is going to be y. So y over what? Hypotenuse. This is the longest side. So y over r is going to be our sine theta. Okay, so keep that in mind. Sine theta is going to be y over r. And we have it on the slides here. You can see that sine theta is equal to y over r. So we are proving for cos theta and then tan theta. Okay, so to prove for cos theta and sine theta, let me quickly erase this. Let me quickly erase this. Okay, so we can continue. So that's sine theta. Let's look at cos theta. So cos theta will give us what? We know that that is so adjacent. This is the adjacent x, and then over what? Hypotenuse. That is r. So that's going to be cos theta is going to be x over r. And then we look at the tan theta. Tan theta will give us what? Tan theta is going to give us, that is TOA. So opposite, this is the opposite. And then the adjacent, that's x. So we are going to get y over x for our tan theta. So just as we have it here, you can find that in our slides, that sine theta y over r, cos theta x over r, tan theta y over x. Okay, and these are not the only trig ratios that we have. There are three more. Okay, we have the cosecant, secant, and then cotangent. And just as these ones have short form, the sine is just sin, that's how we represent it. And then the tangent is what we represent that by tan. Okay, so cosecant is the same as cosec, secant is sec, and then cotangent is what? Cot. And one funny thing about these ones are that they are actually the reciprocal or the inverse of the basic ratios. So cosec is the same as 1 over sine. So cosec is actually the inverse of sine. Okay, and then sec is what? 1 over cos, or the inverse of cos. And then cot is what? The inverse of tan. Okay, one thing you have to know is that these three other ones, the cosec, sec, and cot, they are not normally used. Okay, so if we give you a question and the question is in sec or cosec or cot, in order to be able to work with it well, you just have to convert it into the reciprocal or the fundamental form. Okay, after working, after getting your answer, you can reconvert back into what you were given. Okay, just as you could do when you are given questions in decimal, you can solve it in fraction and then represent your answer as a decimal. You haven't changed anything, have you? No. So we move on. Now let's look at quadrants and their signs. Okay, a quadrant is basically a circle that has been divided into four parts. Okay, so if we have, okay, I think we use this part of our board. So let's go this way. Let's say we have a circle. So we have this nice circle. Okay, if this circle, we know that the angle that the total angle in this circle is what? 360. Okay, so in a situation where we divide this circle into four equal parts, let's divide this circle into four equal parts. So in a situation where we divide the circle into four equal parts, then what is happening? What is happening is that, let me see if I can get the equal parts. Let me see if I can get the parts to be equal. So let's assume these are four equal parts. Okay, if this is a circle divided into four equal parts, then the angles have also been divided. Okay, so 360 divided by 4 is 90, right? So each angle, this angle is 90. From here to that one is also 90. This to that is 90. And then from here to that is also 90. You get it? And each of them is a quadrant. Okay, one thing you have to take note of is that in trigonometry, when we are measuring angles, we start from the right side to the left side, or in other words, we measure angles in an anti-clockwise manner. You see the way the pencil moved, in an anti-clockwise manner. So against the way the clock moves, or counterclockwise. Okay, so if we are moving counterclockwise, then this angle is going to be 0. Okay, from this place to that place is 90. So there's the angle 90 degrees. Okay, from 90, from this place to that place, so this we are moving this way. This is 0, 0, let's say 20, 45, 60, 70, that's 90. Okay, and then from 90 we go to 100, 110, 120, 150, 170. This is 180. So this angle is 180 degrees. Okay, that's the 180-degree angle. And then we move again. So 190, 200, 210, 220, up to 270. Okay, and then from 270 you go 280, 290, 300, 310, 320, up to 360. Let's go this way. Up to 360. Okay, so this angle is 0 and at the same time 360. Okay, but for the sake of calculation, we rather prefer to use the 0 more than the 360. Okay, so there's angle 0, the angle 10, angle 20, angle 30, angle 40. Okay, since we measure in the anti-clockwise direction, this quadrant is going to be called our first quadrant. Okay, so that is our first quadrant. Okay, let me write that. So this is our first. Let me increase the fonts a little. Okay, you let me write first. This is our first, or let me, this is our first quadrant. Okay, so that's going to be our first quadrant. Let me increase the font small so that you're able to appreciate what I'm writing. So that's our first quadrant. So let me move this. This is going to be our second quadrant. Okay, that's our second quadrant. This one is going to be our third quadrant. Okay, and this is our fourth quadrant. So that's our fourth quadrant. Okay, so these are the quadrants. They are in the order in which we move. Okay, since we move anti-clockwise, we are going to meet this one first, this quadrant first, followed by this, followed by that, and followed by that. Okay, now let's move on. So these are the quadrants. Okay, so you know first, second, third, fourth, and then you know the value 0 or 360, 90, 180, 270, and then that's all. Now there is this thing you can see from here, CAST. So CAST, you can form something like cast. Okay, yes, you can form a word like cast. Okay, all that this thing is trying to tell you is that in the first quadrant, all the three major trig ratios are positive. Okay, In the second quadrant, it is only sine that is positive. Okay, in the third quadrant, it is only tan that is positive. And then in the fourth quadrant, it is only cos that is positive. What this means is that all the other trig ratios are negative. You get it? So in the fourth quadrant, sine is negative, tan is negative. It's only cos that is positive. In that same way, in the second quadrant, tan is negative, cos is negative. It is only sine that is positive. Okay, we'll come to that. We'll solve worked examples and then you realize why this is so. Okay, so if you can't use the cast, you see, when you are using the cast, you have to start from the fourth quadrant. So C, A, S, T. But if you want to start from the first quadrant and you still want to remember, then you can use all silly tomcats. Okay, so all silly tomcats. Okay, you know that in Tom and Jerry, Tom was a cat and then Jerry was a mouse. Or is that not it? Good. So you can use that to remember. So we are saying that the angle may be positive or negative. Okay, depending on the acute angle that the angle makes with the x-axis. You know acute angle, right? An angle that is less than 90 degrees. Okay, and then what's an obtuse angle? An obtuse angle is greater than 90 but less than 360. Um, Greater than 90 but less than 180. And then what's a reflex angle? Greater than 180 but less than 360. You get it? Good. So this very thing will come to it. Okay, so you stay cool. We'll come to that. So in trig, positive angles are measured in anti-clockwise direction from the positive x direction, starting from 360 degrees, 0 to 360. So just as I was saying that we measure angles in the anti-clockwise direction. So we start from this line. Okay, this is going to be a horizontal line and then we measure anti-clockwise. We move on. The reciprocals of the basic trigonometric ratios also take the same signs as their basic ratios. So we know that here all of them are positive. Okay, and then we are saying that sine here is only sine that is positive. Okay, you know that um, cosec is the child of sine, is that not it? Because 1 over sine is cosec. Since sine is positive here, cosec is also positive. Okay, yes, but the other trig ratios are all negative. And here, since tan is positive, cot is also positive, but all the others, sine, cos, cosec, sec, they are all negative. You get it? So this is the meaning of the sentence over here. So we move on. Now let's look at what we call complementary angles. Okay, what then is a complementary angle? When we say complementary angles are basically two angles that sum up to 90 degrees. Okay, so when two angles sum up to 90 degrees, then we say they are complementary angles. Okay, and we have something we call the supplementary angles. Supplementary angles are angles that sum up to 180 degrees. Okay, so if I have an angle like 70, okay, so angle 70, how many degrees do I need to get to 90? I need 20. So it means that angle 70 degrees and angle 20 degrees are complementary angles. In that same way, angle 60, what is the complement of angle 60? So if I ask you what is the complement of angle 60, it is 30 because I need 30 degrees in order to get to 90 if I'm at 60 already. You get it? So that's what we mean by complementary angles. Okay, now there's also a complementary relationship. Okay, so just as I said that a complementary relationship exists between sine and cos. Okay, in that same way, there's also a complementary relationship between tan and cot. Okay, so there's something like, okay, let's go on here. So there's something like sine 45 is equal to cos 45. Okay, and then sine 30 is equal to cos 60. Okay, let me write that. So sine sine 30 is the same as cos 60. Okay, so you know that 30 and 60 are complementary angles since they add up to 90. You get it? But then this one is not sine 30 and sine 60, but rather sine 30 and cos 60. Okay, so when I ask you sine 25 is complementary with which angle, you should be able to tell me that is what? It's cos 65. You get it? Because when you add 25 and 65, you should arrive at 90. You get it? So this is the relationship actually. Sine, let's say theta is equal to cos 90 minus theta. Let's think about this well and see. Okay, so we are saying that, okay, there's the relationship. We are saying that sine theta is equal to cos 90 minus theta. This is the fact that we have, let's say, so we put in 40 as our theta. So that means sine 40 is the same as what? Cos. And what is 40? 90 minus 40 is what? Is it not 50? Good. That is 50. So it means that sine 40 is equal to cos 50. Okay, let's try that on our calculator. So on our calculator, um, let's move to the scientific mode. So let's go to 40. So sine 40, let's look for sine. Sine 40 is 0.642. Okay, let's now type cos 50. So let's type 50 and then we write our cos. You see it's also 0.642. You get it? So it means they are complementary. Sine 40 and then cos 50 are complementary. Please, when you are typing this, you make sure that you are in the degree mode. If you are in the radian mode, you may get a different answer. Okay, so make sure when you are working, it should be in the degree mode, not the radian mode. Okay, so let's prove this that sine alpha is equal to cos beta, cos alpha is equal to sine beta, and then and the likes. So let's come to a fresh page. Let's go to a fresh page. Okay, so that's a fresh page. So we are assuming we have this shape. Let's assume we have a triangle. Okay, let me see if I can bring this, if I can copy this triangle. Good. So that's our triangle. Okay, so assuming we have this triangle. Okay, let me write the alpha here. So this is alpha. So this is alpha. Okay, forgive me, but that's alpha. Okay, so that's our alpha. This is beta. We know that looking at cosine and then sine, the sine alpha, sine alpha is going to be what? Using the SOHCAHTOA, opposite over hypotenuse. Is that not it? What's the opposite? A, hypotenuse. C. So we are going to get A over C. Is that not it? Good. And then let's look at cos beta. Let's look at cos beta. We know that cos beta is so this is beta. Okay, so what is opposite? There's the opposite, right? There's the hypotenuse. This is the adjacent. Looking at the beta, not the alpha. Be careful with that. So cat what? Ka, that is adjacent over hypotenuse. So that is cos beta. So cos beta is what? A over C. You can see that this A over C is the same as that A over C is. It means that sine alpha is the same as cos beta. Okay, so sine alpha is equal to cos beta. You get it? So that's what we have here. Okay, in our slides that sine alpha is the same as cos beta. You should also be able to prove on your own that cos alpha is the same as sine beta. Okay, and you should also be able to prove that tan alpha is the same as cot beta. Okay, so let's try that and see. Tan alpha is the same as cot beta. Let's see something. Um, so tan tan we know that tan alpha twa that is opposite over adjacent. Is that not it? What's the opposite? A adjacent B. So that's A over B. Is that not it? Now let's look at cot cot beta. So to get cot beta, you know that cot is the same as 1 over tan. You get it? So it means that cot beta is the same as 1 over tan beta. This is very important. Okay, you should take note of this. That cot beta is the same as 1 over tan beta. Okay, so let's just work with the tan beta. When we finish, we come and find the 1 over. So what is tan beta? Tan beta, tan beta is going to give us what? Twa, opposite over adjacent. So this is beta, so the opposite is what? B. So the opposite is B. And then the adjacent is what? C. Um, Opposite is B, adjacent is A. So B over A. So it means that we had what? Cos beta is equal to 1 over tan beta, where the tan beta we got as what? B over A. Okay, so let me come down and write it here so that you get it better. So cot beta is equal to 1 over tan beta, and then we had tan beta as what? Something something over A, right? That was B over A. Let's cross check so that you are able to follow. So that's B over A. Now it was supposed to be 1 over tan beta, not just tan beta. So we come and substitute. We know that, so cot beta is the same as 1 over, and then tan beta is what? B over A. You know that this 1 over is the same as 1 divided by B over A. We are still finding cot beta. Okay, and you know that in fractions you can't just divide like that. You first have to change the division sign into multiplication sign. As soon as you change the sign, you have to reciprocate the right side. So okay, let me continue. So let me cancel this. So 1 times, you reciprocate to give you what? A over B. What is 1 times A over B? Is still A over B. A over B. Then it means that we are looking for cot beta, is that not it? So cot beta is the same as A over B. You get it? And then we know that tan alpha was also A over B from here. Okay, tan alpha was the same as A over B. So tan alpha also gave us A over B. So even if you don't know anything, since they are all A over B, it means that cot tan alpha is the same as cot beta. You get it? So tan alpha is the same as cot beta, okay? Meaning that there's that complementary relationship that exists between them, okay? So to sum stuff up, sine alpha is the same as cos beta, cos alpha is the same as sine beta, tan alpha is the same as cot beta, and then cot alpha is the same as what? Tan beta. Where this is only true when A and B are complementary angles. That is, when A plus B is 90. That is the only situation where this relationship exists. Okay, so if you have, if I tell you sine 15 is the same as cot 85, and let me come again, sine 15 is the same as cos 85, you should be able to tell me that that is false, because the 15 plus 85 will give you 100, but not 90. You get it? It's going to give you 100. But if it were sine 15 and cos 75, it was going to be correct. You get it? Because the 15 and 75 will sum up to what? 90. You get it? So this relationship only exists when you have what? Complementary angles, or when the two angles added together will give you 90 degrees. You get it? So, and you can see that there's also a right angle triangle. There's a right triangle. Okay. And the sum of angles in a triangle is what? 180 degrees. Okay, this part has taken 90 degrees. So the remaining 90 degrees will be shared by the alpha and the beta. Okay,